Hello and welcome to Prescriptive Analytics. In this lecture, we're going to look at the shortest path problem, which is a special case of the transshipment model. My name is Hari Rajagopalan, and I'll be doing this lecture for you in this lecture. So the shortest path problem is a unique case of the transshipment model where your supply is 1 and your demand is also 1. And in this particular case, we have found that other nodes, supply and demand, have demand of 0. So here's an example of a transshipment problem. We have the American Car Association, and they are looking to plan travel plans. And this could be your Google Maps also. And they want to determine the optimal route for traveling between these cities. And you can either look at the shortest plan or the one which is the most scenic route. So here is an example, it's from and to. This is the driving time in hours, and this is the scenic rating. So you can either minimize your driving time or maximize your scenic rating. So let's look at this problem. Supply is now equal to demand. There's just one car. And you're trying to go from Birmingham to Virginia Beach. And so here are each arc or each arrow contains the time and the number of points. Okay. And you can see here is how it's set up. So given this, we need to, the decision variable is xij, and we're going to either minimize or maximize. In this case, we're looking at the shortest path. So we're going to minimize the time it takes for each arc. All right. And we're going to subject it to node 1 is completely outflow. So the two outflow nodes equal to 1. Then here inflow minus outflow is equal to 0, node 2. And again, node 3 all the way up to node 11 where you have inflow. These are all transshipment nodes. And then final node 12 will be equal to 1. You will notice that I have changed the last node 11 to 1. It should be 1, not 0. And I've made the change here. So let's look at the shortest path. It's very, very simple, easy. Your supply node and your demand node will end up being equal to 1. And all the transshipment nodes, inflow minus outflow, will be equal to 0. So very straightforward. Let's look at it in Excel. And I'm not going to go through it in great detail. I'm just going to show you how it looks in Excel. So here you go. The setup in Excel. You're going to do it exactly the same way as you always done it. You put all the variables here. First row, second row is blank. Third row is setup. And here all these are equal to this. So pretty much, of course, assume non-negative is true. Okay. If you want to make it the most scenic route, you change the objective coefficient, nothing else changes, and you make it a maximization problem. So pretty simple, pretty straightforward here.